field. So as we know, in rainy season we observe thundering and lightning in sky. So Benjamin Franklin, who is one of the scientists who has carried out experiment with a flying kite, was the one that demonstrated the electric nature of lightning. He also suggested that clouds contain electric charges that when released into the sky result in a massive lightning flash. So in day-to-day life we have many examples of the presence of charges within around us. So one of the example is combing your hair. When you comb your hair, there is a friction between hair and comb. Because of that, charges are going to be created. When you bring that comb near to the piece of paper, the comb will attract the piece of paper because of it is electrified. Okay, so another example is rubbing a stones. If we rub two stones, we observe that charges are going to be created. Because of that, we can fire the cotton. So if we rub any two bodies, charges are going to be created. One of the example is rubbing a silk with glass rod. That is also one of the example. So these we have observed ourselves in day-to-day life. So such materials which produce electric charges are called electrics, and the materials are said to become electrified or acquire electricity. So with the many examples in our day-to-day life, we can define the term electric charge. So electric charge is the physical property of matter which causes charged matter to experience a force when placed in an electromagnetic field. We can understand this force and electromagnetic field further. So basically there are two types of charges. One is positive charge and another one is negative charge. So how we can understand the flow of charges? So we have electrostatics, which is a branch of physics deals with the study of electric phenomena where electric charges at rest. So that's why the name electrostatics. And another branch called electrodynamics, which is going to deal with the charges in motion. Okay, charges at rest and charges in motion, we can differentiate them. So what happens if we bring two charges, like charges and unlike charges? What happens to them? So like charges and unlike charges we can understand with this figure. If two positive charges or two negative charges which are like charges, they repel each other, they move away each other if they come closer. And unlike charges, positive or negative, if these opposite charges come closer, they attract each other. So the force of attraction or repulsion will depend upon the like or unlike charges. So the unit of this charge is given by Coulomb, that was given by the name of scientist Coulomb. So that's why we have the law called Coulomb's law. We will discuss next in the next slide. So the magnitude of the charge is given by 1.6 into 10 to the power minus 19 Coulomb. So one of the fundamental law or the famous law of electrostatics, that is Coulomb's law. So it was given the name because of the scientist Augustine Coulomb. In the year 1785, he has explained there is existence of force between two charges. So according to this law, the force of attraction or repulsion between 2 point charges is directly proportional to the square of the product of charges and inversely proportional to the square of the distance between them, and the direction of this force will lie along the line joining the two charges. Okay, this law is called Coulomb's inverse square law. So we have this formula. So if we remove this proportionality constant, this will be equal to, that is ratio 1 divided by 4 pi epsilon naught, which is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. And if we substitute this constant value, and here this epsilon, which is given by product of epsilon r and epsilon naught, that is for relative permittivity of a medium epsilon r, and epsilon naught is the relative permittivity of free space. So this is the statement of Coulomb's law. So we have a vector form of Coulomb's law. So we can see in this figure, if we have two charges, the force acting on Q1 is Q1 and Q2 are mentioned here. So if the force exerted on Q1 due to Q2, which can be written as here, the force on Q1 due to Q2, that is F12, and Q1 due to Q2, that is F21, which are given here. These two forces are equal in magnitude but opposite in direction. So what is the importance of Coulomb's law? So this Coulomb's law is helpful for the point charges separated by very large distances or small distances. For example, if we take atom, the atomic distances or atomic size is around 10 to the power minus 11 meter, and if we go to the nucleus, nuclear distances are around 10 to the power minus 15 meter. So therefore, this Coulomb's law is helpful for explaining the force which binds electrons within the nucleus in an atom, or two or more atoms, molecules, or many atoms in solids or liquids. So what is the comparison between Coulomb's force and gravitational force? We have four fundamental forces in nature. So this Coulomb force, nothing but electrostatic force, and gravitational force. Why we have taken these two forces? Because these two forces are called inverse laws, inverse square laws. So what is the comparison between them? So if we take Coulomb force, that is electrical force between two charged bodies, is given by this formula, that is Coulomb's law. And gravitational force, we consider this force which is acting between two masses of the bodies. Okay, Coulomb force is between two charges, okay, separated by small distance, and here two masses of the body separated by a small distance. And here, like Coulomb's force, we have the constant. So here G is called the gravitational constant, and its value is mentioned here. So another difference is Coulomb force is always attractive or repulsive, and gravitational force is always attractive. Okay, and third difference is Coulomb force is Electrical force depends upon the medium between the charges, whereas gravitational force is independent of the medium between the masses. Okay, and the fourth difference, that is Coulomb force is much stronger and gravitational force is weaker. So next we go to the electrostatic field. If we understand electric charge, then we can understand electric field. So this we can define as the space surrounding the electric charge in which another charge experiences a force that may be attractive or repulsive is called electric field, or the region in which electric charge experiences a force is called electric field. Okay, that is the region that is surrounding the electric charge, we call that as a field, that is electric field. So this electric field arises from a potential difference or voltage gradient and can exist when charge carriers such as electrons are stationary. So according to Coulomb's law, at the point the test charge Q experiences the electrostatic force, as we can see in the figure, capital Q and small q. Small q is called a test charge at a distance r from the charge Q, capital Q. So the force we can have, that is Coulomb force, we can write the formula easily. Then the electric field, if we want to define, this electric field is given by the force per unit charge, so F by Q. Okay, if we substitute, then the electric field is given by 1 divided by 4 pi epsilon naught capital Q by R square. Okay, so this is the formula for electric field. Then we can have the relation between force and field, that is given by F equal to Q into E. With the help of this, we can define the intensity of electric field, that is at a point in an electric field is the ratio of the force acting on the test charge placed at that point to the magnitude of test charge. That is electric field, we can define it as force per unit charge. Okay, this is all about electric charge and field. If you like, if this video is helpful, please like, share and subscribe my channel. Thank you for watching.